solving quadratic equations. Let's kind of take what we've been doing and relate it to graphs for a minute. If you solved a quadratic, let's say I gave you x squared minus x minus 6 equals 0. And I told you to solve that. What would you do?
Find A, B, and C.
Okay, you could do your ABC and do quadratic formula. You could complete square, or you could even just factor nicely. This one just breaks down. If it works, that's the fastest method, but certainly the other options still would work. What multiplies -6 and adds to -1? Okay, and then what would you do? Set them both to 0. So we get 3 and -2. Alright, we've done that. If you were going to draw a graph, go ahead and go to your graphing calculator, plug in x squared minus x minus 6. What's the graph look like? Parabola. Where do the 3 and -2 come into play? Those are your zeros, or your x-intercepts. So you touch the x-axis at -2 and +3, and then you get something like that, right? What would cause a case where your graph looked like this? Yeah, in the quadratic formula, that's when you get the 0 for your discriminant. Or in solving the equations, that's when you had a multiplicity of 2. You get the same answer out twice. Is it possible for your quadratic to never touch the x-axis? Sure. What if I gave you one and it looked like this? It doesn't have any x-intercepts. What does that tell you about the solutions when you solve that thing, Cody? It had the eyes. Those were the imaginary, the complex ones that we talked about. Okay, so we're going to take these pieces of information and use that to solve quadratic inequalities. So when we're talking about inequalities, we know we get our solutions. Those are the x-intercepts. I can ask you questions about if your graph is greater than 0 or less than 0. So on this graph, greater than 0 would be when it is above the x-axis. Less than 0 would be when it's below the x-axis. Okay? It's possible, like if I gave you this one down here, is that one ever below the x-axis? No, it's never negative. This one is never positive. So we're going to be talking about these quadratic inequalities, and we'll use the graphs to help us. And like I mentioned before, it is possible to have them that never touch the x-axis. So let's say I gave you this inequality. I'm going to solve x squared minus x minus 12 is less than 0. Alright, first step, I want you to solve it like it equals 0. So go ahead and factor. Okay, so now I want you to go ahead and just find out what makes each piece equal 0. So first you're just finding the x-intercepts. You get 4 and -3. If I were going to graph these things, so there's an x-intercept of 4. There's an x-intercept of 3. -3, excuse me. I know a little bit. I probably don't even need my calculator to graph this. Does this quadratic open up or down? Up, because it's a positive x squared. Now, if you needed to double check something, could you plug it in your calculator? Absolutely. thinking when this thing is less than 0? Less than 0, is that above or below the x-axis? Below. So I'm looking for that little piece. So you're going to give me an interval. Negative 3 to 4. Would they have parentheses or brackets? Here. There's no equal to right there. So I don't want to include when it equals 4. So in this case, they're both parentheses. So what that says is any x value between negative 3 and 4 would make this original inequality negative. If I plugged in a 2, I get 4 minus 2 minus 12, that's less than 0. I can check it really quickly. What questions do you have right there? I want you guys to try one. So this one, you can still factor nicely. Multiply to a negative 15, add to negative 2 would be negative 5 and positive 3. So then, if I set each piece to 0, I get positive 5 and negative 3. So those are the two places where you touch the x-axis. This one opened up because it was a positive x squared. If I can grab where that would help. We wanted less than or equal to. So that's going to be everything between these points, including those points. So it would be bracket negative 3 comma 5. Is that okay with everyone? Let's look at this problem. Alright, first step. What do I need to do?
Did you do your ABC thing opposite
You can do your quadratic formula here.
the
That'll work. Any other options? Anything else you want to try? Does this one factor? How would you factor it if you wanted to? You would have to do the full box method. Both options are going to work. I'm going to go ahead and do box method, but you can do whatever you prefer. So we have to do the 2x squared, negative 12. Those things multiply to a negative 24. And I need them to add to a positive 5. So what numbers would work? So when we factor, we get x 4, 2x minus 3. So this factors x plus 4 times 2x minus 3. Alright, so at this point, set each one to 0. I get a negative 4. 1 more. Okay. So those are the two times where we touch the x-axis. What answer did I want this time? Greater than or or equal to. Greater than means above the x-axis. So I'm talking about the ends here. So we have to write an interval for those. This one is coming from negative infinity. Stops at negative 4. We had the equal to, so that's a bracket. Or you could start at 1.5 or your 3 halves and go to infinity. Questions on that? I want you guys to do one like this. So it's not a 1x squared, so you have to do the full box method. Multiply to a negative 12. Add to a negative 11. So it would be negative 12 and positive 1. We get 3x and 1, x minus 4. So set each one to 0. And we get negative 1/3 and positive 4. So think about your graphs. You're touching the x-axis at negative 1/3 and 4. We wanted greater than 0, not equal to, just greater. So we're talking about the two ends of the graphs. So that would be from negative infinity to negative 1/3 and from 4 to infinity. Are those okay? I want to take a look at a few more. Okay, first of all, if you're going to do box method, what has to be true about your square term? Has to be positive. So what do I need to do first? Okay, if you multiply by a negative 1, what happens to your inequality? It flips. Now if I go to do my box method here, I need two numbers that add to, or multiply to 15 and add to negative 1. Are there any numbers like that? No. So box method is not going to work. Then how else can we solve it? Quadratic formula. Okay, so x equals opposite of b, so opposite of negative 1 would be 1, plus or minus the square root of b squared minus 4ac all over 2a. And you need to know that for your quiz on Wednesday. Okay? So if I start working this out, I get 1 minus 60, so that's negative 59 over 6. What do you know right now? Yeah, this is imaginary. If I am trying to solve this, am I going to graph imaginary numbers? No. So you could keep breaking this down, but you don't really have to. Right now I know this is imaginary. So there are no x-intercepts. So either everything on this graph is going to make it true, or nothing will. There's no alternative there. So go ahead and let's just graph. You could really graph either one. Let's just go with the original. So I want you to plug this into your graphing calculator. you graphed this one, so your intercept was at +5 opening up. You graphed the original, it's at -5 opening down, but either way, they'll both tell you the same. If I graphed the original wanted to know when this thing was greater than 0. Is this one ever greater than 0? So my answer right now is no solution. Right, this had no x-intercepts. Now, if the original had been less than 0, what would my answer have been right there? May have been a positive infinity, because everything would make it less than 0.
Is there any way to like know before you work it out if it's gonna be like that? Or you
If
have
it's
to
going to be an
know?
imaginary,
Yeah.
not really. You need to go ahead and you could do the discriminant, I suppose, the b squared minus 4ac, but you can't just look at it and know at the beginning. What if I gave you it's illegal. What do I need to do first then to fix it? Okay, so if I bring over my x squared, good. Okay, so if I try to do box method here, it's a 1x squared, so we can do the shortcut. Are there two numbers that multiply to -4 and add to -2? No. So we've got to do quadratic formula. Opposite of b plus or minus the square root of b squared so I get 4 plus 16 plus 20. How would you break down a 20? Square root of 4 is 2. Okay. Definitely not a pretty answer, but we got an answer. Now we need to figure out what this is going to look like. You are welcome to use your graphing calculator to kind of help you. Let's just graph this one right here. Upside down. And those are approximations because we'll have, when we write our interval, we're going to have to use the exact, the 1 plus or minus radical 5. Okay, I wanted up here it was less than or equal to 0. So is that the middle or the ends? The ends. So it's going to be negative infinity, comma, this first point would be 1 minus radical 5. We had an equal to, so that's a bracket. Union, the next point starts at 1 plus radical 5 and goes to infinity. So if they don't factor nicely, you'll have to use quadratic formula, and those exact values are what you use in your interval. Don't give me a decimal or try to estimate it. Just keep it exact. Questions? I'd like to do one last problem. I'm done. step. We can just factor this one, can't we? Alright, two numbers that multiply to positive 1 and add to negative 2 will be negative 1 and negative 1. So if you solve this, both of these turn out to be x equals 1. So when you graph it, you get one x-intercept at 1. Okay. I want to know when this is greater than 0. Is it always greater than 0? Almost, except right there at 1 it equals 0. Now if I had a greater than or equal to right there, your answer would just be negative infinity, positive infinity. But because I don't want when it equals 0, it's from negative infinity to 1 with a parenthesis, union 1 to infinity. By putting those parentheses on the ones, I'm taking out that 1. And that's only because I did not have an equal to 0. I only wanted when it was positive, not when it equaled 0 itself. Any questions here? What if I asked you, how many solutions are there to the equation f of x equals 3, right here. F of x is the same as y, right? If I say y equals 3, y equals 3 would just be like this. How many solutions are there? 2. There are 2 times when that parabola equals 3. Right here and right here. If I had said f of x equals negative 3, how many solutions would there be to that? None. It never hits negative 3. What if I said f of x equals 0? How many solutions? 1. That's what we've been doing in all of these. But we could really be finding when it equaled any y value. Alright, I'm really done now.